I am Isaac Edwards with Virtual Virginia and want to thank you for reviewing my EcoHouse proposal. The location of this project was a central consideration since we will need access to building materials and energy sources. The Shenandoah Valley was selected from this project because it has an abundance of natural native materials and has a moderate climate and does not experience too many weather extremes. The valley is only a short drive to the cities of Charlottesville, Richmond, and Washington, D.C., and a day trip to the beach is not out of the realm of possibility. Also, the valley's location at the foot of the mountains with bodies of water scattered throughout make it an ideal location for recreation and to soak in natural beauty on a daily basis. With all this beauty, who wouldn't want to live in the valley? Another important consideration in location of the eco-house is the air quality of the location chosen. In the Shenandoah Valley, air quality is generally good and only occasionally reaches the moderate level. You can see from the information obtained from airnow.gov that the air quality deteriorates somewhat when the temperature rises, but is good during low to moderate temperatures. Since the Shenandoah Valley is considered to have a temperate climate generally, the air quality will be good. Next, we will need to look at the options for energy sources for the eco-house, such as solar energy, wind energy, and biomass. The proposed eco-house boasts a 24-panel solar system. With this system, 93% of the energy needed by the eco-house will be supplied by the solar power, and the system will pay for itself in 9 years. The other two options which were considered were wind and biomass, and were found to be the least viable energy options. Wind turbines are most effective when installed near the coast or offshore. To be effective at energy production, wind speeds must be at least 13 kilometers per hour on a fairly consistent basis. Biomass using wood and crop residue is used by Dominion Power only in Southwest Virginia. Thus, solar energy is the most viable energy that is alternative. An experiment was conducted to determine whether wind energy would be a viable option for the eco-house in the Shenandoah Valley. For the experiment, a wind measurement tool was made. The wind was measured at 8 a.m., noon, and 8 p.m. for 5 days. For the 5-day period, wind speeds averaged out to be 4.93 kilometers per hour, and there was only one day that the wind speeds were at least 13 kilometers per hour, which is the speed needed to make windmills efficient. Thus, wind energy was not a viable alternative. The slide shows a sketch of our proposed eco-house. As you can see, it has a 24-panel solar energy system and utilizes Xeriscape for landscaping. Additional eco-friendly items such as rain barrels, recycling, LED lights, insulation plumbing, and drywall alternatives will be discussed further on in the presentation. To test the environmental impact of the eco-house, an impact diagram was made. Each of the components needed for the eco-house could impact the environment negatively through emissions. We can change these negative environmental impacts by using more environmentally friendly and less toxic materials. The impact diagram and research showed that we can make the most difference to the environment by using alternatives to drywall, insulation, and plumbing. Standard drywall amounts to approximately 26% of all waste from new construction, about 3,000 pounds of waste per home. However, there are alternatives to drywall such as cob, lath and plaster, and straw. The eco-house will have interior walls made of cob, which is a mixture of clay, sand, and straw. Cob walls, which are located near windows, will absorb heat during the day and release it at night, which will also help with energy usage. Standard insulation is made from toxic substances which are harmful to the environment. Standard insulation also is a poor insulator. Alternatives to standard insulation include cotton, cellulose, wool, and soy-based spray. Insulation in the eco-house will consist of a soy-based spray because it is plant-based, will reduce the emission of fluorocarbons, and is a better insulator. Most plumbing systems use PVC pipes which require petroleum drilling. Environmental impacts include pollution and destruction to the environment due to drilling. Alternatives to PVC pipes include copper, cast iron, and vitrified clay, and HDPE. Vitrified clay, copper, and cast iron are very expensive, but vitrified clay requires little energy to manufacture. HDPE is inexpensive but uses fossil fuels in the manufacturing process. For the eco house, we will use HDPE for the supply line and vitrified clay for the waste lines. This will cut some of the expense while also reducing some of the impact on the environment. The eco house also includes the features of LED lighting to reduce the overall energy use. LED lights are up to 80% more efficient than traditional lighting, such as fluorescent and incandescent lights. 95% of the energy in LEDs is converted into light, and only 5% is wasted as heat. Recycling and compost bins help to reduce the amount of waste in landfills. The use of recycled food waste as compost improves soil health and reduces the need for fertilizers and pesticides. Xeriscaping will be used in place of standard landscaping. Xeriscaping can reduce landscape water use by 50 to 75%. Additionally, xeriscaping requires less maintenance and water requirements are low. Lastly, rain barrels have been placed on the side of the eco house. The water stored in the rain barrels is better than drinking water for washing cars and watering indoor and outdoor plants. Rain barrels will also help reduce stormwater runoff from the property. I've enjoyed working on this project and preparing this proposal. The most intriguing part of the project was discovering more eco-friendly building alternatives. I have listed my project resources in case you would like to review any of the components in greater depth.